Hello participants. In today's class, I will introduce you uh, statistics. This field is very important as far as mm, data science is concerned. Whole concept actually revolves around the statistics, and we will see there are two different branches of statistics. That one is descriptive statistics and inferential statistics. So we will discuss. Uh, I will introduce you statistics in this class. So in last class, I discussed different dataset repositories like Kaggle and UC repository, and we have seen how can we access these repositories as well. And I discussed four data sets that we will be using throughout the data science course. So I also suggested you to download those data sets and keep it with you in your Google Drive so that you can perform different activities and exercises later on in the weeks. So in current week, I will be covering these important concepts. So I will introduce you statistics, that is the part of current lecture. Then I will also introduce you descriptive statistics. Then I will discuss inferential statistics. And next I will discuss introduction to hypothesis and finally probability. So these are the contents of this current week. As far as this lecture is concerned, so I will introduce you statistics. Then further I will discuss descriptive statistics, types of data, describing data. How can we describe the data? So these part will be covered in current lecture. Now the question arises, what is statistics actually? So statistics is the science of collecting, describing, analyzing and drawing inferences, that is modeling from data. So there are four different words here: collecting, describing, analyzing and drawing inferences, which are very important here. So collecting, it means collecting those data which are meant for your purpose. Let's say you are working in healthcare system. So you need to collect the relevant data. Describing, it involves describing this collected data that you have collected through figures and graphs, creating a picture that speaks louder and clearer than words. So that is the motive behind describing. The next is analyzing. So analyzing the data is where the magic happens actually. You are trying to turning raw numbers into meaningful insights. So that is the purpose of analyzing. And drawing inferences, it means you are trying to modeling something where you want to predict and forecast, saying not just what the data is, but what it could mean for the future. So you want to predict something, suppose. So you want to look into the future. Statistics not just about numbers and graphs, it is about what these numbers and graphs represent about the real world, right? And again, statistics is the art and science of learning from data. So I would say that is the backbone of whole data science. We want to learn from the data. We want to take some insight from the data using the statistics parameters. Suppose you are working with a party, and your motive is to find which party will win the current general election, right? Suppose someone is working in that area and they want to know which party will win in the current general election. So obviously it is infeasible to survey all citizens. India is very huge country, and you cannot survey all the citizens. You cannot ask every citizen to what are their preferences. So what we will do, we'll consider proportion of the population. So we want to take some sample and we want to perform certain statistics on those samples. Similarly, suppose a company has launched a new product and the company want to know how people react to this particular product. So again, it is infeasible to survey all citizens. So what we will do, we will consider proportion of the population. So we will take certain sample and that is proportion of that population. Now what is population then? So total elements or objects that we are studying, right? You can see here there is a population, a figure where several papers are there. So that is the population. Sample is subgroup of the people that we study to draw inferences about the population, right? We cannot, survey all the citizens or we cannot consider all the population. So what we are doing, we are taking sample from that population. So the quantity estimated from a sample is called statistics. So actually we will try to estimate from that sample. And this is the part of statistics. So mean, median, variance, standard deviation computed from a sample is called statistics. So we'll see how can we calculate mean, median, variance, standard deviation in today's lecture. Now, what are the different types of statistics? There are two main branches in statistics. The very first one is descriptive statistics. This involves summarizing and organizing data so that it can be easily understood. Right? And descriptive statistics can be broken down into measure of centrality and measure of spread. Like you want to find out mean, median, mode. So that is the measure of centrality. Similarly, you want to find variance, standard deviation and range. So these are measures of spread. The next branch is inferential statistics. This involves making predictions or inferences about a population based on a sample of data taken from the population. It includes estimation, hypothesis testing, regression analysis and others. So we'll see how we can perform hypothesis testing in next lecture. Regression, and what about regression analysis? So regression analysis is a set of statistical methods used to estimate relationship between a dependent variable and one or more independent variables. So we have seen in a last lecture that when I was discussing data set. So in data set we used, suppose I want to predict lung cancer, right? And I have all the relevant data with me. So prediction of lung cancer. So this is the dependent variable, right? And other parameters such as BP level, blood pressure level, age, and other parameters. These are independent variables. Now we will focus on descriptive statistics. So descriptive statistics can be broken down into measures of centrality and measures of spread. So what measure of centrality says? It actually include the mean, median and mode which are used to find the center of a data set. Right? We want to find out these values, and on the basis of this we will measure the centrality of the set of the data that we are having. Measures of spread, these include range, variance and standard deviation which are used to find the spread or dispersion within a data set. So we want to find how our data is dispersed and how much it is scattered. So we want to find these values. So for that purpose, measures of spread is required. We will explore each measure in detail, understanding how they are calculated and what they tell us about our data. So we will be exploring this in today's lecture. Now, if we are talking about descriptive statistics, so again, we need to know what are the different types of data. So, according to the types of data, descriptive statistics will vary. So, we will see what are the different types of data, how can we describe qualitative data and quantitative data. So, what is qualitative data and quantitative data, that we'll discuss. How can we describe relationship among attributes? So, these need to be these will be discussed. So, what are the different types of data? So, we are having qualitative data and quantitative data. If I will further partition qualitative data, then there is a nominal data and ordinal data. As far as quantitative data is concerned, so we are having discrete data and continuous data. So, what is qualitative data? So, those attributes that describe the object using finite set of discrete classes, right? So, suppose there are different colors, right? Red, blue, green, and you want to, distinguish different records on the basis of color of, suppose you are storing the data of employee, those who are wearing red color shirt or blue color shirt or green color shirt, right? So, this one is the nominal data. There is no such ordering in that data, right? There is one more type of qualitative data, that is ordinal data. So, there is actually some order exists in that data, in that attribute, like poor, good, excellent. So, we can say there is some order in that data. So, that is the ordinal data. Now, as far as quantitative data is concerned, so attribute having numerical values and are used to count or measure certain properties of sample. So, like quantitative data could be, number of eggs or number of kids, so these are quantitative data that you can quantify. Again, this can be divided into discrete data and continuous data. So, discrete data, those quantitative attributes which can take only a finite number of numerical values, right? Like the case with number of eggs in a basket, number of kids in a class, number of Facebook likes. So, you cannot fraction it, right? So, these are finite numbers. So, like suppose number of wins in a season. So, number of wins cannot be 2.5, 3.5, right? Number of votes in an election, again, this could not be 1000.5, right? So, these are discrete data. And continuous data, those quantitative attributes which can take fractional values, like body temperature, right? Suppose 37.5 degree Fahrenheit or 100.1 degree Celsius and so on. Wind speed, water temperature, volts of electricity, latitude, longitude. So, these can have fraction values as well. So, these are continuous data. Now, we will focus on statistical analysis. So, in this statistical analysis, it actually depends on the type of variable. So, the type of statistical analysis depends on the type of variable. Type of variable, it means whether you are having qualitative data or quantitative data. So, if qualitative attributes are there, so what is the average color of the shirts of all the participants? So, you cannot, ask this type of question, right, which is not suitable for qualitative attributes. So, what is the total number of frequency of color of the shirts of all participants in sample size? That is the right question, right? So, each color would have certain frequencies. So, that is the valid question, but you cannot say average color of the shirts of all the participants. So, for qualitative data, we will find out the frequencies of each and every category. So, again, regression analysis is not valid because this is not in case of qualitative attribute, classification can be performed, but regression analysis is not valid in this case. Then, as far as discrete quantitative data is concerned, so we can ask what is the average number of students enrolled in last 10 years. So it is possible. We can perform regression analysis, right? And mean, median, mode. We can calculate mean, median, mode, variance of data, because this one is having discrete value, right? So this statistical analysis can be performed. So it will vary. Statistical analysis will vary which type of data you are having, whether it is qualitative data or quantitative data. And how can we describe qualitative data? So the values of categorical data is usually having repeated value, right? Categorical data, it means like that I was discussing, color of shirt, right? So it is having qualitative data, and there are certain, you can make it in different categories of different colors, right? So frequency of value is possible in this case. So number of times low rate is given to a product. Suppose you are giving a rate to a particular product, right? So the number of times low rate is given to product, it is a valid statement as far as qualitative data is concerned. How many times the red color appear in the data? Again, this is possible in qualitative data. So the count of total number of times a value appeared in data is called frequency, right? How many times a product has got low rate, high rate. So these are count of total number. So that is the frequency. Frequency plot is useful to describe frequencies of data. So we will see how what is frequency plot and how it can be designed. So frequency plots are useful in analyzing errors in machine learning. So you can analyze errors on the basis of frequency plots as well. You can see the variation between different plots. On the basis of that, you can analyze the errors as well. Now, how can we describe quantitative data? So for discrete data, we can find frequency, and for that purpose, histogram is useful. So if you are having discrete data, like in this case, I have given a table here. So suppose there are certain intervals 0 to 10 and the frequency is 126. It means 0 to 10, these number of elements are there. Suppose I am storing value of a particular player, cricket player, who has scored different, depending on different interval, right? So suppose cricket player X has scored between 0 to 10, 126 times. Similarly, he has scored between 10 to 20, 59 different times, right? So you can see here interval is there. So you can see the last interval, that is 190 to 200. So that player has never scored any run between this interval. And between 180 to 190, he has scored once. Suppose he might have scored 182 or 189 and so on, right? So these are certain frequencies. So we can plot the histogram using these interval. I will show you how histogram will look like. Let me come to that histogram. So this is the histogram for the data that I was talking about, right? So you can see here between 0 to 10 there are certain I think 128 or 129 instances are there. Similarly 10 to 20, 20 to 30, 30 to 40. So this one is the histogram of that particular data, this particular data. So for continuous data, we can also find frequency using histogram. We can also find frequency as well depending on this histogram. We can also adjust the bin or class. I have taken bin between 0 to 10, right? I can adjust it, I can make it 0 to 5, then 5 to 10, 10 to 15, 15 to 20 and so on. I can also increase the mean between 0 to 20, 20 to 40, 40 to 60. So I can vary this one. Choosing the right mean size can provide useful insight. So it can, you can compare the score of two different players, how they have scored. Between 0 to 10 and 10 to 20, how they have scored, and which one has scored more in a particular interval. So this type of analysis can be performed. We can also compute cumulative frequency and can compare multiple histograms. So cumulative frequency, you can see that there is a column at right side. So cumulative frequency is actually frequency plus the previous frequency, right? Like in this case 126, the cumulative at very first instance, cumulative frequency is 126. Now in the second case, add it with the frequency of the next interval. So 126 plus 59, right? Then at third interval, it should be 185 plus 44 and so on. So in this way, whole cumulative frequency can be calculated. That would be useful later on. Describing quantitative data. So frequency polygons I was talking about, so almost identical to a histogram, which is used to compare sets of data. It is very much similar to histogram. So how we calculate, how can we draw frequency polygons? So sort the values. First you need to sort the values. Choose the class interval, like in this case, choose the class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40. Then compute frequency of each interval that we have calculated. Compute midpoint of each interval, right? So you need to find out the midpoint. Where is the midpoint? In case of 0 to 10, the midpoint is 5. Plot the frequency above the midpoints. Like in this case, let me show you how it will look like. So this is the frequency polygon or frequency plot of the previous histogram, right? So I have taken midpoint of each and every interval. So this is the polygon frequency plot. Now there could be different type of histogram, like left skewed histogram, right skewed histogram, uniform histogram, symmetric histogram. So what is left skewed histogram? Most of the short bars are towards left, right? So this is the left skewed. The last one is the left skewed histogram. So or shorter bar is at left side. Then right skewed histogram is most of the short bars are towards right. So that is the right skewed histogram. Uniform histogram, most of the bars are of similar height, right? Symmetric histogram, bars are almost mirror image. You can see, like in this case. The very first one is symmetric histogram, so it's a mirror image almost. And the mid one is right skewed, or you could say it is also called positive skewed. And the next one is left skewed, which is also called negative skewed, right? So in case of left skewed, why we are having, what is the importance of left skewed histogram, right skewed histogram, and so on. So a left skewed histogram suggests that the bulk of data values are concentrated on the right side, right? In case of left, because shorter bars are toward left, so the bulk of the data is at right, right? With fewer values, fewer low values are at tail. It means your lower values are at left, and higher value are at right. And conversely, a right skewed histogram suggests that most data values cluster on the left side. So in right skewed, most of the values are at left side, with the tail stretching to the right due to fewer high values, right? So this could be very much useful. For example, in income distribution, a right skewed histogram indicates that a large number of people can earn below the average income, which might impact economic policy decision, right? So if we are having right skewed histogram, right, it means we can that actually indicates something. In case of that I have given you an example. So right skewed histogram indicates that a large number of people earn below the average income, right? So which accordingly the policy maker can take certain decision, right? So this would be very useful uh, diagram, or very useful for the data analysis. So symmetric histogram, actually if I will calculate mean, median and mode, so all would be at in same interval, and that you can see here. So admit all the values will be there, mean, median, mode. If the right skewed histogram is there, so mean would be higher than median, and mode would be again the largest bar is there, so there would be mode. Then in case of left skewed, so mean value would be less than median value, and mode will remain at the largest bar. So this type of analysis can be performed if we draw a histogram, and we'll see how we can calculate mean, median, mode, that we'll see. So use of histogram in machine learning, identifying discriminatory features, which is very important, right? So what we can do, plot the histogram of frequency polygons for blood pressure level for diabetic or non-diabetic patients, right? So you are having data set in which there are certain patients are diabetic and there are certain patients who are non-diabetic. We have already seen that data set, that is the P-Indian diabetes data set. If the trends for BP level at very different are very different for diabetic or non-diabetic patients, then BP level is a good discriminative features. It means if the trend is very much different, suppose you draw a histogram of frequency plot and you observe that trend is very much different. For non-diabetic patient, BP level is low, right? Not low, I mean within the range. And for diabetic patient, you found BP level is high or not in actual range. So this could be the BP parameter, BP level parameter would be a discriminatory feature, very important feature as far as diabetes prediction is concerned. So in this way, we can calculate whether a feature is discriminatory feature or not, whether a feature is having importance in the machine learning process or not. Similar to histogram, we can also create stem and leaf plots, and it is an efficient way of describing small to medium data. So stem and leaf plots look like histogram inverted form. So like in this case, what is a stem and leaf? So stem is the stem is composed of the leading digits of each number in the data set. So you are having digits like I have given an example here, 2, 3, 5, 7, 11, 13. So the leading digit would be, for single digit, I am considering leading digit as a 0. Consider 2 as a 02, 3 as a 03, 5 as a 05, 7 as a 07. So the leading digit is 0 in this case. So I will first plot, I will consider it as at stem. So 0 would be at stem, again 1 would be at stem, and the leaf will be, the leaf is the next significant digit to the right of the stem. So in case of 02, 03, 05, 07, so I will keep 0 at stem and all the values 2, 3, 5, 7 would be at leaf. Similarly, for 11, 13, 17, 19, the leaf, the stem would be 1 and the all values 1, 3, 7, 9 would be at right. Similarly, for 23, 29, then 31, 37. So actually it is creating an interval, if you will observe. So the very first one is the interval between 0 to 9. Similarly, the second one is interval between 10 to 19, right? So, and the value at the right, that is left, it is actually the actual number, you could say, or the count is there. So, if I am considering interval between 0 to 9, so the total instances is 4, right? And if I am considering an interval 10 to 19, so the frequency or count would be 4. And in this case, I can in the similar way, I can create the whole stem and leaf plot, which is very much similar to histogram. And the benefit is, we can find out the actual value as well, right? Besides finding out the count, I can also find out what are the actual values, right? Like in this case, 0 to 9, I have actual value 2357. Between 10 to 19, the actual value is 1379, and so on. So, similarly, there is one more important diagram that is called scatter plot, that describe relation between different parameters. So, there could be different relation between attributes, not for qualitative variables. Again, this is not for qualitative variable. Actually, scatter plot is for quantitative variables. You will observe linear, quadratic, exponential, or mix of relation. So, any type of relation could be there. Like in this case, there is a linear relationship between cells and temperature. As temperature is increasing, cells is also increasing, right? So, there is a linear relationship. And if two features are so related, then in machine learning, we used to feed only one feature among two, right? So, if two are very much related, like in this case, cells and temperature is very much related. So, better to drop a parameter. So, we have already seen, heat map in last class, where I have shown you how parameters are correlated with each other, right? So, I have drawn a heat map. So, how to draw a heat map using Python, that we'll see using Seaborn and Matplotlib. But the crux of this story is, if both are related, if two features are correlated, then we can drop a parameter as far as modeling is concerned. To summarize this lecture, so what I have discussed in this lecture, so I described basics of statistics, what is actually statistics is. Then I discussed descriptive statistics and different type of data as well. What are the different type of data, qualitative data and then quantitative data. Then I discussed histogram as well, which is very important as far as if you want to find the discriminatory features. Then we have also seen frequency plots, which is similar to histogram. So, these I have discussed in this current lecture. Again, I am stopping here, and I will discuss in next lecture. I will discuss the remaining part of descriptive statistics. Thank you so much for joining this lecture. I will meet soon.